This is the presentation for Milestone 3, Reverse Engineering, Precision Manufacturing, and DFX Analysis. The presentation will cover the methodology involved for 3D scanning and the engineering design process. Reverse engineering is a process where an existing device, component, or system is analysed with the intent to understand how it works, to replicate or enhance it. The reverse engineering process is the same for all systems. It begins with the extraction of information which is used to understand the components and how they interact with each other and their environment. In this case, 3D scanning is a method for extracting information. The next step is the modelling of the object, where the acquired knowledge is combined and tested in a model. To create a model, we first convert the 3D scan into a mesh model, and then convert that into a CAD model. This can be used to visually interpret the data and make changes. The final stage is review, which includes the testing of the model and its ability to meet its intended use. This is part of the engineering process, which includes improving the design and developing a manufacturing process that is most suitable. The component selected to reverse engineer was a clutch housing. The part is of circular geometry with a hole through the center for a shaft to sit. The purpose of a clutch is to engage and disengage power transmission through a shaft, often used to change gears. The clutch is often subject to high temperatures due to its operation being friction dependent. The combination of high temperatures and the repetitive compressive forces within a clutch can result in the wear of its components. The housing may crack, reducing its efficiency, and may cause damage to other aspects of the system. The complex geometry of the system will take many man-hours and hand measurements to accurately remodel a broken housing unit. The part must also be very precise, as inaccuracies will result in a dramatic reduction in efficiency, as rubbing and wearing may occur. For these reasons, 3D scanning was used to generate a CAD model to reverse engineer the clutch housing.
It is now accessible to everyone. The RevoPoint POP is the first high-precision, cost-effective 3D scanner available with ultra-precise accuracy for pixel-perfect 3D prints. Until now, 3D printed to those with strong digital sculpting skills. But with RevoPoint POP, the limits are endless. It features 2 scanning modes, handheld and fixed, for a variety of opportunities to texture map anything, anywhere. One cable connect to your laptop to quickly obtain the highest single frame accuracy of any object with either a turntable to quickly acquire a full 360 mesh build, or go handheld to capture unique organic shapes, both large and small. RevoPoint POP is able to capture fine details like nose contours, wrinkles, or high-definition texture colors for accurate organic scans. With an eye-safe infrared light source for picture-perfect 3D scans, generated by our free-access, simple-to-use, intuitive RevoPoint software. No training required. Just fast, accurate mesh construction in the palm of your hand.
The next step in the reverse manufacturing process is to merge the raw point data from the 2 scans and transform it into one STL component file. This represents stage 2 on the slide, Revo Studio. Several software features are utilized, including clipping, isolation, hole filling, simplifying, alignment, and meshing. The alignment tool is a process combining the 2 scans into one single scan and is done first. Revo Studio will prompt the user to identify 3 shared points on each scan to help compute the complete geometry. Isolation. This feature automatically identifies and deletes point cloud data that is detached from the main body of the part, resulting from errors in the scanning process. This is an important step to eliminate unnecessary noise. The clipping tool allows for further manual removal of unnecessary points in the file. This is a simple task involving clicking and highlighting the desired areas to be deleted. The hole filling feature automatically detects and fills in any holes on the surface of the part file to ensure it is a complete geometry. Simplify. This function eliminates unnecessary point cloud data that does not improve the accuracy of the scan. This function can also reduce the number of polygons in the mesh file while retaining as much detail as possible. This feature is crucial in minimizing the size of the part file so it is compatible with CAD software. For SOLIDWORKS software, it is ideal to have a maximum vertex count of 20,000. Meshing. This step is required to convert the point cloud data into a mesh 3D model that can be identified by the CAD software. After all of these features have been utilized, the 3D component is complete and ready for processing in the CAD file. The final step is to save it as an STL file.
And in this slide I'm gonna be presenting about our model, discuss about the engineering design process, and present about some alternatives manufacturing process for our model. So the first one is the metal casting. So metal casting is a 7,000-year-old process that is used in both fine art and manufacturing. So usually the molten metal is moved from a crucible into a mold to create a positive metal cast object. So once the mold and metal are cooled, the object is removed, and metal casting can also further be distinguished into two categories. So the first one is the processes with expandable molds, and the second one is the processes with the reusable molds. So expandable molds casting is a process that is suitable for single use or temporary molds. In this process, the molds are usually made from the foam, plaster investment, ceramic shells, or the resin bonded sand. So the process is still in use due to the fact of being inexpensive and relatively fast. Therefore, for small volume manufacturing, expandable mold casting is the best option. However, in our case, we're going to be choosing the non-expandable molds since they are permanent and reusable. In general, they are designed in a way to withstand the hot temperatures of the molten metal. Since our product is made of steel, this process will be very suitable to produce our model. But usually, metals like cast iron or steel are used to make the permanent molds, and therefore it is another point that is proved to be suitable for our product. Non-expandable molds are also ideal for creating multiples of the same cast metal object. So, like I said before, those are the reasons that makes metal casting suitable to produce our product. And the next one is the computer numerical control CNC machining. So the CNC machining is a modern, efficient, and automatic subtractive manufacturing process that allows manufacturers to make repeatable parts of consistent quality from a wide range of materials such as metals, composites, or plastics. In these days, most industries, starting from the automotive to medical, use the CNC machining parts. So machining is common to produce tools, parts, and metal objects. So such as some metals such as aluminum, titanium, steel, and copper are used the materials that can be machined. So above all the materials, steel is used for the precision machining due to its advantages to resistance. Its advantages of resistance to corrosion and its tensile strength. So aluminum is also inexpensive, easy to shape, and the process possesses lightweight. Copper, on the other hand, is strong and versatile, while titanium is resistant to corrosion. So all these metals can be used for the CNC machining. However, as I've mentioned above, our model is made of steel, and therefore machining will be another suitable manufacturing process for our product. And the last method that I have got is the metal forming. So the metal forming is a fabrication process that uses metal tubing or sheet to produce structural components and parts. So during the operation, the process will deform a metal workpiece to a desired geometric shape. Metal forming process is also vital for the automotive and aerospace industries, as it can mass produce several parts that are mainly used by those industries. There are also lots of popular metal forming processes, some of which will be stated, but the one common characteristic of all metal processes is that they reshape any raw material stock into a finished part. Since metal forming is also very well popular and well used often in the industry. Lots of alloys can be used for this process as well. So the most common metals are aluminum, copper, brass, and steel. Since steel is one of the suitable alloys, metal forming process is suitable for our model as well. So overall, I would like to say that the project was a mild success with the reverse engineering process, harvesting a 3D model that strongly resembled the original artifact with some minor modifications. In this case, I would like to point that these modifications were required due to the challenges of 3D scanning an object with an extremely complex geometry with several holes. Therefore, to capture the entire model, we perform multiple scans of both sides of the artifacts, and therefore forcing the need to merge multiple points in cloud files. So this was a challenge utilizing the alignment tool in Revol Studio and resulted in a model with several unnecessary data points. To remove this unnecessary data, several Revol Studio tools, including the clipping and isolation features, were utilized. One very successful element of the project was that the teamwork displayed by the entire group. So each team member was extremely diligent, making scheduled meetings and then accepting responsibility for different elements of the project. In addition, each team member was extremely responsive and helpful to one another, which is reflected in every making contributions to both the data processing and presentation. One improvement for a future project would be beginning the 3D scanning stage earlier. As the team was slow to begin this crucial phase of the project, we felt forced to continue with the challenging and complex geometry of the chosen artifact. Therefore, an improvement for the team would have been spending more time sampling different objects in the 3D scanning phase and choosing the best design option. And thank you very much.